Guys, sorry I'm not there today, but I'm making this video for you, and if it seems a little weird or there's some weird pauses and breaks or you heard some weird noises, my sick son is sitting in my lap right now, so we'll see how this goes. Please make sure you're on page 5 of your notes, and we are going to start with lenses. Okay, so before we were dealing with mirrors where the light was being reflected, now we're going to be dealing with a lens and the light is going to be refracted as it goes through. Says we're going to be looking at a double spherical lens, and basically we're going to see that either both sides are going to be concave or both sides are going to be convex. We're not going to have to look at any lenses where one side is flat and one side is concave or convex, or one side is convex and one side is concave, which is kind of typical of like your glasses. That's the type of lens that you would find. But we're only going to look at lenses that match up to the same side. Okay, so convex lenses are also known as converging lenses because the refracted rays that pass through can converge. Right? Convex lenses, they will make real or virtual images, and you'll see throughout our examples. And it's going to all depend on where our object is, outside of the focal point or inside of the focal point. Concave lenses are called diverging lenses because the rays always diverge. Concave lenses can only form virtual images, and so similar to our last one, the second type of lens that we're going to look at is going to be pretty straightforward, and there's not a whole lot of variation. So let's look at the convex lens first. Okay, convex lenses. So we have Q, right, is the center of the lens. And what you're going to want to do, and I'm trying to draw with a mouse, so excuse my drawing, but you're going to want to kind of draw a line down the center of your lens because that's where you're going to have the light refract. What really happens in a lens like this, if I can get this out of the way, is light is going to come through, right, and at this boundary it's going to refract, and at this boundary it's going to refract again, and right, following our rules, the angle's going to get the angles are going to change. Oops, I might have drawn that backwards. Where, let's see here, where light's going to come through, right, if this is the normal, it's going to, oh yeah, it would bend down. It was going to bend down getting closer, and then when it comes out it's going to get further away again. So if I was trying to over exaggerate, right, it's here, then here, then here. That's basically what's happening each time that a light goes through. Realize we're not going to draw it like that. What we're going to do is we're going to have this line go down the center, and we're just going to have it bend at that center point and then go from there as far as our ray diagrams. Okay, so we have an F and an we basically have two focuses, right? We have a focus on each side. Realize that if the object was, over here, right, the whole idea is that your eye is over here and that light is traveling through the lens to your eye. Now, regardless of how these lens diagrams go and where we're forming an image, that'll dictate whether the image is real or virtual, but what's really happening, right, is the light is going through the lens. Now, if an image forms over here where the light travels and it's on the side that your eye would be on, the opposite side of the object, it's going to be a real image. If something were to form over on this side, the same side as the object, it's going to be a virtual image because light is actually traveling through the lens to your eye. It's not traveling and forming this image here. Okay, let's move on. So, the three rules that we have here are 1, 2, and 3. They're going to match up with the 1, 2, and 3 from this picture. So keep that in mind as we're working through it. So, looking at our rule 1, right, we have rays that are parallel to the principal axis. So our ray 1, right, if this is our object, rays are going to come in parallel to the primary axis, or the principal axis, and you can see that we have this line that's drawn down through it. You're going to then refract through it and draw it going through the focal point on the other side of the lens, as seen in the picture. Our second ray, kind of like that one that used to go through the center of curvature and reflect back on itself, right? This ray is going to go through the center of the lens, and then it's just going to keep going in a straight line to the other focus. Sorry, not to the other focus, but just straight line, right? Straight line through it. So you're going to, right, obviously always start at the top of the object, and you're going to line up your ruler to this mark and then just keep going. As in the other one, you started at the object, tried to go parallel, and then went through the focus. And our last ray is going to go through the focal point on the same side of the lens as the object, right, which I was just showing here. And then it's going to, right, once it hits the lens, now go parallel to this primary axis shown. And that's really it. So you're always going to do those three lines just as before. You might not always be able to draw all three depending on where the lens is, where the object is, but those are the lines that you're going to draw. Now you will have to do some back ray tracing, as you're going to see in some more examples. Okay, so here is our drawing that we were using above, and as you can see, where the lines intersect, the same thing happens where this is our image. So we know that this image, right, is inverted. It's magnified when you're comparing it to the height of this object, right? This one's a little taller. So it's inverted, it's real. The light rays are really traveling through the lens and focusing in on this point. And like I said, inverted and magnified. Okay, so let's look at the other scenarios. Okay, looking at our other scenarios, wow, these lines are off. Okay, it says that here's a virtual image formed from a converging lens. Notice that the object is inside the focal point. And that's what's going to happen. When the object is inside of this focal point, it's always going to make an upright image. It's always going to be magnified, and it's always going to be virtual. Right now, your eye, you're over here somewhere looking through this lens, right? And so because the light where it forms this image isn't actually over here on the side of your eye, that's why it's a virtual image instead of a real image. And our last scenario is if the object is placed at the focal point, no image, right? These lines are parallel to each other. If you back ray trace them through here, they're going to be parallel to each other, and they're not going to form any image at all. Okay, I tried to clean up this image at the top. So just to make sure you know, right, you're going to go primary, let me choose a different color. You're going to go parallel to the primary axis, right? And then you're going to go through the focal point, hard to draw with the mouse, right? And then you're again going to go through the center of the lens. You're going to see, wow, that's really bad. You're going to see that these two lines, as shown, are getting further and further apart, so they're never going to cross each other to form an image. So when you do the back ray tracing, those lines are going to get closer and closer together, and so the back ray tracing lines are going to then meet at a point, and then you know you have an image. Notice that there's not a third line drawn, because if you go from the center of the object through this focal point, right, that light is never going to go through the lens, therefore that's not needed because it doesn't go through the lens. Okay, so to a concave lens. Okay, it's always going to form a virtual image, and so the two rules that we're going to follow are here, right? Oh, there we go. We got all of them at once. The parallel ray is reflected as if it had started out at the focal point on the same side of the lens. So what you're doing, right, is you're having it come in parallel to the axis just like before, right? But now it's going to refract and move away from this focal point. So when it shoots out this way, you know how to make that ray by back ray tracing through the focal point on the same side as the lens. And then for the second one, right, it's going to go through the primary, or through the center of the lens, right at the axis, and travel through. So you can see in this picture it's reversed, but where these two meet right here, the actual light that goes through this point, that goes through the lens, and the back ray tracing from here, where that meets, that's where the image is going to form. So it's going to be the same every time, and this one's a little different because it's an actual light ray and the back ray tracing, but it should be the same each and every time as you're forming your image. And so here's kind of a final product of it switched, where this here, just so that we're straight, this here is the object, right, and this here is the image that's formed, and it's a virtual image, right, because it's not on the side of the lens that the light travels through, it's on the same side as the object. That's why it's virtual. Multiple lenses, we don't want to do that yet. So just to review, right, if this is that focal point, right, and this is the object, if the object is outside of the focal point, you can see it's over here, it's inverted, and it's a real image. As you come closer, right, the object's getting closer to the lens, the image is getting further away from the lens, that distance is getting greater, but you can see that the image is getting bigger. Now the object height is 0.05, the image height is 0.07, so it is magnified in this. So as this object gets closer, the image is going to stay inverted, but it's going to get bigger and bigger and bigger. And so you can see, right, it's through the focal point parallel to the axis, through the center of the lens parallel to the axis, and through the focal point on the other side. And so as they move, those lines are staying the same. And you can imagine the image is getting bigger and bigger and bigger, but further and further away as it comes in. Now when it gets to that focal point, you don't get anything. There's not going to be any image. Now when I'm inside the focal point, and it's hard to see, but these lines are now getting further and further apart. They're converging somewhere here in the distance, and so now you can see they're starting to converge. And so because those lines are converging, where the back ray tracing of this one and the back ray tracing of this one form, you get this image, right, that's large and that's magnified and upright. Hopefully that makes sense. Okay, concave image, right? No matter where we are, you can see that it's always forming a virtual image. It's always on the same side of the lens as the object, therefore it's virtual. And just like before, right, our line goes parallel to the axis, it refracts away from the focal point, so you back ray trace through this focal point so you know where to draw it. The next one goes through the center of the lens and straight through, ignoring the purple one because you're not going to know where to draw that one. That doesn't really make any sense. It's all based off of, you can see it's changing with the, where it's hitting the lens is changing with the height of the object, so you're not going to know where to draw that one. So you're just focusing on this one through the center of the lens, and this one that's parallel and then refracts away from the focal point, and you back ray trace. So just like before, right, this is the actual light ray traveling, where that actual light ray matches with the back ray tracing of this yellow one, the one that was parallel. That's where your image forms, and again, always upright, always virtual, and always smaller than the object. Oops. So that's it, 16 minutes long. Please make the rest of your ray diagrams for all of your lenses. We'll check all of them tomorrow or Wednesday, depending on when you're in class. And fill out that chart just as before, where you're saying whether the SO or the SI, right, the distance to the object is the SO, or the SI, the distance to the image, which one is greater than the other. And same thing with the height, which height is greater, the HO, the height of the object, or the HI, the height of the image. Hopefully this wasn't bad, and please ask questions when I return.